Okay. Hi, guys. I'm back. Sorry, this is just, it's lovely fun. Trying to get everybody back in. Try and get my little document camera running back up. Okay. Okay, there we go. Okay, so there we go. We're back. So hopefully, okay, we'll be able to get through this other stuff here pretty quickly as we're processing forward. I'm not going to try and necessarily rush us through anything, but I am going to try and get us through it since I'm not going to have to be explaining what a confidence interval is or anything like that, okay? So that's kind of where we're going. Now, for this one, we are going to be bringing back, let me switch over, okay? We're bringing back that p hat equals x over n, okay? Okay, so now then, when we get ready to do this, okay, and so when we talk about our margin of error, the margin of error is now going to be z sub alpha over 2, so that's going to stay. We're still going to be using the same thing there. But what's going to happen is this other piece is going to be p hat 1 minus p hat over n. Okay. Now, when I am processing this stuff, I'll try and keep most of this math done kind of in a couple of steps just so that you can see it and then process forward. Okay. So we're still going to be using that same z sub alpha that we had before. So if we take a look just at finding p hat first, okay, so just working from there. If they tell me x is 44 and n is 96, okay, so just using that for the first part, p hat is going to be 44 over 96, which is 0.4583, okay, and again, I probably rounded that as that went through, okay, and I'm gonna want to make sure I'm checking something real quick. Okay. Okay. Sorry guys, I'm trying to okay, I'm back. Okay, so we now have this. Now then, from here, if they want us to build, okay, a confidence interval, okay, so the first thing, okay, that I'm going to need to do from here is I'm going to need to get my z sub alpha over 2. Now, they want us to build a 90% confidence interval. That's what they're wanting us to build on this. So again, I'm going to cheat, okay, and use my little chart down here. Okay, I'm going to move this down. Whee! Focus. There it goes. Okay, so for a 90% confidence, we're going to use 1.645. Okay, so that's the one that we're going to be using. So I'm going to pull this back up. Hopefully it'll readjust. Okay, this is 1.645. Okay. Now then, in order to now build our confidence interval, okay, we're going to plug into this formula to figure out our margin of error. So we've got 1.645 m times square root 0.4583, 1 minus 0.4583 over n, which was 96. Okay. So I have, pull that on the calculator. So 0.4583 times 1.1 minus, 0.4583. And then I'm going to divide that by 96. Okay, I've got 1.645 times the square root of 0.002586. Okay, so I'll do the square root of that, and then times our 1.645, and this gives me 0.0837 when it's rounded, okay? So there's our margin of error. So now, if I want to build my confidence interval, same thing that we've done before, okay? Try to move this over just a little bit, okay? We're going to be 0.4583 minus that 0.0837 and 0.4583 plus that 0.0837, okay? So those two values, okay, are going to give me 0.4583 minus 0.0837 is going to be 0.3746 and 0.542. Okay, so this is now our confidence interval, the same way that we made one in the last one. You are going to see that this stuff is decimal things, okay, when this is processing as we're going through here, okay. And again, this is section 8.3 that we are in, okay, as we're processing forward with this stuff. So again, this is 8.3, because again, we do this stuff, this chapter is done slightly out of order, but it's so that the processes remain the same as we are moving forward in the information, okay. Now then, couple things that we have to kind of make assumptions for with this is that we are doing a simple random sample for this stuff. Oh, standard error. Standard error is this part. Whatever this comes out to be, this is your standard error. Okay. It's, in other words, it's this calculation or this math that's right here. Okay. So if you're looking at, I know you're probably looking at like number 1 on the example problems. And so we did, this answer was part A. I kind of skipped past, you should get something like, you should get something like 0509. Yeah, I'll leave this up here for just a second, okay? You should get that the standard error is 0509, okay? And then the margin of error is this one, okay? So this is our margin. Okay, so that's our margin of error right there. Sometimes they will ask for this stuff in those 3 parts. They'll ask for like, what is p hat? What is the standard error? What is the margin? Oftentimes though, they just go find p hat and then what is the confidence interval? They kind of process all the way through down into going straight from here over here to this confidence interval, okay? So I'm going to leave that up there for just a second here. And then I'm also going to show you guys, there is a way to do this on the calculators. And so I'll have to kind of we'll go in and process. There's not really a way to do it for the stuff that we saw. I'll go back and talk about how to do the stuff for the 8.1 so that you can see where to do that, and the 8.3 kind of all in one time, just so that you understand where this stuff is. There is a slightly different one that we'll use over in 8.2, but we'll handle that when we get there, okay? So I'm giving everybody a shot because I know I was bringing all this up when we were going through the stuff. So I will talk about how to do this over in the calculator, just so that you know how to do that, and I will do that one over on number 2. There will be a little bit of stuff that we'll need to do as far as numbers wise to make that all happen. Okay. Okay. So let that all stay up there. This over just a little. So if you're trying to find everything. Okay. Now, just kind of talking through where all this stuff is going to go. Okay. And I am going to kind of step back into our section 8.1 for this, just so that you know where this is at. Okay, got it. Okay, so now going back to, pull this down. So stepping back into section 8.1, if you're wanting to do this on a calculator, okay? And I am by no means saying that you have to do it on a calculator, but I'm gonna give you the option, okay? So, and I'm gonna try and do this as best I can. Okay. So on our calculators, and this is again for section, sorry y'all, I am not multi-handed. Okay, so we're going back for section 8.1 here just for a second, okay? What you're gonna do is you're gonna press the stat button, okay? So you're gonna go to stat. Now then, when stat comes up, you should have edit, calc, and tests. You're gonna go over here to tests, okay? And for section 8.1, you are going to use option number 7, okay? So we're gonna come down here to this Z interval, and we're gonna press enter, okay? Now, you can either do data or stats. We're gonna put in stats, okay? Because we're gonna give it all of the information that it needs to know. So for example, and I'm just gonna go back and grab one of those other examples that we had already done, okay? So the one about the 62, this is number 4. Okay, so talking about number 4 here, we had that sigma was 9.2. We had that the standard, or the mean was, sorry, 50.87. N was 62, and they want us to do a 95% confidence. Now notice, the C level, that is your confidence level, so that is 0.95 when this is done, and then we're going to hit calculate, okay? There is the confidence interval, so 48.58 to 53.16, and this is the same one that we got when we ran this, okay? So it will process. I think there is a general that either it does 2 decimal places or it does the match on whatever X bar is. So since X bar has 2 decimal places, this did 2 decimal places. Now, moving into the one for 8.3. Okay, so I'm going to change our number here. So now we're going to move to 8.3. I'm going to press clear here. Sorry, I'm waiting on everything. Okay, in order to do this, we're going to go into stat again. We're going to go over to tests. So again, we're going over tests. Now, for this one, okay, we're going to do option number 5, okay? The one that says one prop. Now, prop here means proportion, okay? So we're doing a one proportion z-test. And again, okay, now, oh, sorry, I misspoke. We are doing, it's down here. It's down on the bottom. It is option A, okay? It is the one prop Z interval, one prop Z interval, option A that's down here, okay? So it's gonna come up with, and guys, this one, you have less stuff that you have to put in. So if you're taking a look at number 2, okay? Number 2, where it asks you to do, they give you X is 53, N is 68, and this time it asks us to do an 80% confidence interval, okay? So I'm going to put 0.80, and then I'm going to tell it to calculate, okay? And now it is going to give me 0.71497, and then it's comma 0.84385, okay? So it ran kind of 5 decimal places. That proportion is a non-ending decimal when it found it, so it does show you p hat. Okay, so it's a little bit shorter. Now, it is still doing, which number is what? Are you talking about which option number on the calculator? Oh, number 2. This is example 2 on, so if I go back into stat and tests, okay, the 53 and the 68, these are the values that are coming off of, these are coming right here off of question 2 out of the section 8.3 handout, okay? Hopefully that clarifies what we just did. And again, just sticking all that in there. Okay, and that ran through there, okay? Okay, so now then, moving along. So again, you have your choice as to whether or not you want to get, so again, in 8.1, we were using the Z interval value. In 8.3, we were using the one prop Z int. Okay, so those are the ones that we've used so far. Now, guys, the same rules apply as what we saw over in 8.1. If you up the level of confidence, so you go from an 80% confidence to a 90% confidence, that interval is going to get wider, okay? When that happens. If you stay on the same confidence, so if you do 80% to 80%, but you up the sample size, so you get up to a higher sample size, then it is going to decrease that interval, okay? That is correct, okay? Now, you can find your margin of error. So it will not give you your standard error, and it will not give you margin, but you can find it. So for example, on the last one, on that number 2 one that I just did, okay? One of the options that you have, go back and find something. Okay, so one of the things is they gave us that p hat was that 0.77941 basically, and then we had our interval was 71497 to 84385. Okay, one of the things that you can do, okay, is to find your margin of error, you can take p hat and subtract the lower amount. So if I did 0.77941 minus our 0.71497, we get 0.06444. That is going to be your margin of error. Now, you can also check this by doing the upper one minus p hat. The concept here is p hat is right in the middle of here. So if you did the 0.84385 and subtracted the 0.77941, you get the same 0.06444. So you can find a margin of error from the calculator values. You do have to do a little bit of work. It will not tell you your standard error. So if you're asked to find standard error, you are probably going to have to run through. Now, keep in mind that for the standard error formula, okay, so talking about standard error formula, the standard error is that square root p hat 1 minus p hat over n. Okay, so you don't necessarily have to have a confidence level or a confidence interval amount in order to calculate that standard error. So you wouldn't have to have anything that you looked up from a chart or anything like that to find that value as you were processing that and moving forward, okay? Now, for this one, we also have the minimum sample size the same way. And again, what they did is they calculated and they took that margin of error formula, the one that had that z sub alpha in front of the thing that I just had, and they solved for n. So this formula is, there we go. So it's going to be p hat 1 minus p hat times z sub alpha over 2 over m squared. Okay. So this is your, and again, always round up. Okay. Always, always, always round up. Okay. So if we take a look at number 5, taking a look at number 5 on here, it says a sociologist wants to do a 99% confidence interval for the proportion of children's ages 8 to 10 living in New York who own a cell phone. We've got a survey by the National Consumers, okay, that shows the proportion, so p hat, is 0.27. It asks what sample size is needed so that it will have a margin of error that is 0.02. So this is all the information that they give us. Now then, again, I can cheat and look, and I'm going to try and bring this up into camera for us without having to move stuff around. Okay, for that 99% confidence interval, we're going to use that 2.575 value. Okay, so z sub alpha over 2 is 2.575. Okay. So now pulling this into formula, we've got 0.27, 1 minus 0.27 times 2.575 over 0.02 squared. Okay, so this is what n is going to be. So this is 0.27 times 0.73. Okay. Okay. So I took this and divided and got the 128.75. I did this subtraction, squared this, and I got this 16,576.5625 number. These two multiplied together gave me this 0.1971. When I multiplied those together, I got 3267.24. It does not matter that that is a 0.2 and your rounding rules say to round down. You always round up to this one, okay? So that is going to go up to 3268, okay, is where that is headed. Okay, so hopefully now, sometimes, okay, there is what occurs or what happens in this is that sometimes they don't have. So in the first one of this, they told us that the proportion was 0.27. They don't always know what the proportion is, okay? So when they don't know, okay, so I'm going to kind of, okay, this is, we know p hat. If we don't, then the formula that we're going to use is 0.5, 1 minus 0.5. We're going to assume that it's a 50-50 shot at it. And if you put the first two parts of this together, you get 0.25. Okay, and so this is if we don't know p hat. Okay, so if you don't know p hat, this is the formula that you're going to use. So if you look at 5b, okay, so if we look at number 5b, it says estimate the sample size needed if no estimate of p is available. So this is where I don't know what this is. Now, they're still using the same bit of everything else. So this is still that 2.575 that we had before. The margin of error was still 0.02, and we're still going to square that, okay? So now I have 0.25 times, and then this number was that big 16,576.5625. And this comes out to be 4144.14, which we're going to send over to 4145. Okay, so I'm going to bring that down a little bit so that you can see all the math there, okay? Again, you always round up with this, okay? Now, pretty much anytime we don't know p hat, we're always going to need more people than if we didn't know p hat, okay? And so you have to kind of watch for those things. Usually they are really kind of blatant about, they specify and they say something like a prior estimate is known to be, this is valued at something like that, okay? Okay. Now then, the last section that we've got to do, this 8.2 section, okay? Where this came from, okay? And I'm gonna switch over here so that you guys can see me for a second. Where this one came from is there was a guy who this was I think 1800s, early 1900s when this was going on. And there was a company, they were in the food and beverage industry, and this was kind of before, like, there were no computers, there was nothing like that. They were trying to do some quality assurance and some quality controls that were going on. And so they knew that there was a way to use statistics to do it, to kind of ensure that quality control was processing. And so what, they hired this guy that was a mathematician, and they basically said, we're going to give you like a few samples. And he goes, well, you can't do that. I need to have sample sizes of like more than 30 to be able to do this. And they said, no, because if you have that many samples, you might can figure out the recipe for what our product is. And they didn't want to do that because at this point, they were really the only ones in the market that were creating this product. So they didn't want that out. So he starts trying to figure out how he can deal with this situation. And so what he decides is, instead of there being one bell curve, he decided there was a family of bell curves. So when we talk about our bell curve, okay, shape that we have, the concept here is the less samples I have, the more we have to squish the top of the bell curve. So when we squish the top of the bell curve out, the outside tails are going to kind of kick up a little bit. And so what he did is he created a family of bell curves based on sample size. Now, the higher the sample size went, the more the bell curve kind of started to move up and turn into the regular bell curve that we're used to, because the central limit theorem would kick on. And so what happened, he realized that this had more applications. And so he wound up publishing a paper, and he named, or he wrote the paper under an alias of student T. And so the charts have now been called the T distribution charts. This is another set of tables and charts that I will be providing for you, and I'll show it to you a little bit tonight as we're working through. I'm going to hope I can do this in the next 8 minutes. If not, we're going to start another meeting again, because they're going to run me out of time again. So I'm sorry, guys. What's going on with this one is, I'm going to start by showing you the tables that go with this. As soon as I can find mine. Okay. Now then, I'm going to start with the T distribution tables, and I'm going to pull this up under here. Okay, and I'm going to turn these. Okay, now, here's the deal with this. First off, this table is done to the right. Okay, so when we're looking at this table, we're being done to the right. Now, the other thing that you're going to notice is we're talking about area in the right tail. So the same way that you've done the cut in half bit that you've done before, we have all this. Now, the other thing is we have degrees of freedom. Okay, guys, degrees of freedom is n minus 1. So I'm going to change this back. Okay, I'll come back to this table when we need it. Degrees of freedom is n minus 1, okay, when that process is through. Now then, if we take a look at, say, number 1, okay, the first one asks us to do an 80% confidence with a sample size of 7. So what that means, thinking back to our bell curve, that is 80% in here, that's 20% outside, divide by 2. This is 10% or 0.10. I realize that's a little faint. You may not can see that. Okay, 0.10. You know what, guys? I'm going to go ahead and schedule another session of this just so that I've got it. Hopefully that'll schedule out for me fairly quickly. Okay, so what we're going to do, now then, I'm going to try and zoom in here so that you can see where I'm at. Okay, so 0.10 is here, okay? Then we're going to come down. Now, N was 7. That means we're going to go to line 6, okay? So our number would be this 1.440. okay? So our number would be 1.440. Now, what's going to happen here, bring this all back into play, okay? Instead of Z sub alpha over 2, okay, this was in the old section, this is now T sub alpha over 2. And so we got that our T sub alpha over 2 was that 1.440, okay? And that's what we got for that one, okay? Okay. Okay, I think I've got another chat set up or another video one set up here in just a second if all of this just, you know, doesn't happen. Okay, taking a look at B, okay, so kind of moving towards that one for B, it says we're going to do 98% and our sample size is 10, okay? So again, thinking about our bell, 98% is in here. We've got 2% outside. Cutting that in half, this is 0.01, okay? Do watch your values, okay, with this stuff. So here we are again. Let me bring this in. So here is our 0.01 column. Our sample size was 10, so we subtract 1 for degrees of freedom. So that means we're going to go to line 9. We're going to come down here. Line 9 is this 2. Let me see if I can get it in here. There's line 9. Coming across, we are at 2.821. Okay, so again, 2.821. So our T sub alpha over 2 is 2.821. Okay, for that value. Okay, so now then, the way that we are now going to build our confidence intervals, okay, because I'm going to use this session as long as I can, okay, is our formula for margin of error is now going to be T sub alpha over 2 times S over square root of N. So very similar to the one that we had before, okay? Before we had Z and sigma, and now we've got T and S, okay? Now, if they ask, okay, that is your standard error, okay? So if that comes up where they ask you to find your standard error, that is the standard error, but this is your overall margin of error, okay? So, okay, so now then, looking at an example here real quick, okay, we're going to look at number 2, okay.
What is the use of ID?
N is 51. They tell me that my sample mean is 55.2, and we have a sample standard deviation of 9.3. They want us to do an 80% confidence interval. Okay, I'm going to cut here now, real quick. Here's your ID for the next meeting. Here's the new ID meeting. Okay. Hopefully everybody gets it. This next session should be really short because we're just going to do a couple more examples and process. I'll show you how to do it on a calculator, okay? So this is your new ID meeting. So I'm going to cut this one off and I'm going to go get the next one started, okay?